Welcome, everybody. We have a special episode of Midcurve today, leaning a little more towards the right curve for it. But we have some guests from the technical side behind the scenes that are helping power Solana. So today we have Brennan Watt from Anza and Lucas Bruder from Jito Labs. Brennan, as a first-time guest on Midcurve, you want to give quick background on yourself so people know where you're coming from?
Yeah, sounds good. So hi, I'm Brennan. I'm the VP of Core Eng at Anza, and that means I essentially do whatever I can to make Agave, which is the client that powers Solana, make the client fast, efficient, reliable, all those good things. So I've been at Anza since we did the spin out from Solana Labs. I was at Solana Labs for a couple of years before that, and before that I was at some big tech companies like Facebook, Microsoft, places like that. And my tech background is really strong on the storage side. I've built SSDs, storage platforms, and then kind of over the last 5 to 10 years have branched out to be more of a generalist and work on everything. So it keeps it fun, keeps it fresh, exciting.
Nice. You want to go ahead, Lucas?
Yeah, I'm co-founder and CEO at Jito Labs. We build software, stands on the shoulder of giants at Anza to also help we're mainly focused around MEV software. So trying to help make the network more efficient with, in addition to what Anza's doing, and help make validators and stakers more money. And we started 2021, and my background is in computer engineering. So I did a lot of firmware and robotics before starting Jito. So pretty deep in the weeds, but today kind of just similar to what Brennan said, just hop around between whatever the hottest fire is at the time.
Yeah. I mean, I think you guys both have somewhat of an interesting vantage point on how Solana core has evolved, right? So back in even 21 and 22, it was principally just Solana Labs was doing everything and kind of unilaterally deciding the roadmap of the network as well as the decisions. And today, that process has gotten a lot more decentralized with obviously Firedancer building a second client from scratch. And then Jito now has kind of an interesting role of modifying the core client without, kind of in a hybrid way. So I mean, Brennan, like how has it changed for you guys from being the only person driving the ship into kind of this hodgepodge that we have today?
Yeah, so I'll kind of divide it into two pieces. On the culture front, I'm happy to say that I don't think it's really changed a whole lot, even as we've grown. I think there's like a really strong, awesome winning culture that's been set from the top, and as new people come into the ecosystem, they kind of get introduced into that culture and adopt it. And I think that's great. It actually reminds me of some of the best parts of the Facebook culture, where everyone's really just focused on shipping changes, shipping services, shipping things that actually matter and impact user experience in a good way as soon as possible. So I really love that piece. Now, on the more process side, that like absolutely has had to evolve and mature over time. Um, the number of like smart people that I see walking around our core dev meetups is absolutely insane. It's awesome, but also smart people don't always agree on everything, and so we need ways of settling some of those technical disputes and coming to consensus and making sure that we make progress. And so, yeah, like I do think fondly of some of those days a few years ago where we could just like settle governance and protocol changes and design decisions just in a pull request. It was a very low friction way of doing things, and it was fun. But like, there's just a lot more necessary friction in the process now. We have more stakeholders. We have a lot more value at stake. And so yeah, I mean, like by going slow and having more people involved and more big brains, I think that we're ultimately coming to better decisions. Now, that said, like we have to make sure we don't let that friction manifest as like ossifying the current state and ossifying the protocol. I've seen, this happen some places before where like you think doing nothing is the lowest risk thing. And I think that doing nothing is actually the highest risk thing. We have to like continue iterating, continue making things better.
Yeah. And I mean, Lucas, like how has it felt for you? Before kind of, I think you would talk to them some, but Jito was quite small and it was mostly just kind of layering in a specific change. Now, you're kind of part of a larger group that has input on the roadmap for Solana Core.
Yeah. I think the culture is that Brennan's talking about is one of the main reasons that I was super attracted to Solana. The there's a lot of grittiness, and the meme was chewing glass. There's still some element of chewing glass today, but it's gotten much better. And I think that the grittiness is what attracted me to Solana in this green field, and a lot of that still exists today. We have, we talked to Anza and Fire Dancer team decent amount, and uh, Double Zero, and there's a lot more stakeholders involved. But I think the grittiness and the hunger from all these people are still there. It's like the job's not finished, or IBRL, and there's a few sayings that kind of go around in the Solana ecosystem that are all just kind of circling this concept of just continuing to move fast. So there's still a culture moving fast, and um, yeah, I would say that the doing nothing or slowing down is probably one of my biggest fears, not only at Jito, but also just in the Solana ecosystem. I feel like we're straddling the line of trying to take long-term views on protocol changes, but also getting a lot of stuff done and trying to find easy wins where you can that have really large improvements on the network.
Yeah. And I mean, I think it's funny, like conceptually, progress should have slowed down a decent amount just based on the coordination. And I think there's also some features that are like being held because Fire Dancer going live is obviously a major priority. But at the same time, we'll talk about this more later, but like the network has gotten substantially better over the last 12 to 18 months. And so like from a user perspective and from a statistical perspective, it's actually increasing at a pretty rapid rate. And so, I mean, is there something that's changed at Anza, Brennan, that you would say that's enabling it to continue to kind of improve while still dealing with more of the coordination challenges that you have now?
Yeah, I think some of the investments that we paid a couple years ago are like really paying off now to allow us to continue to improve. And I think people really notice this with the V2.1 rollout and all the very noticeable macro changes there. A lot of what enabled that is some of the infrastructure and testing and resiliency and some of those things that are harder to notice, like paying those up front, that now allow us to move faster. And I think also, we did slow down a couple things to allow the jump in the Frankendancer, Fire Dancer teams to catch up. But taking advantage of some of that time, we still had a lot of work to do, and so there were a lot of kind of little things to go clean up while we weren't making big sweeping protocol changes. And some of the less sexy but super important work of optimizing memory allocations, not having extraneous memory allocations in different places, and all these like little small improvements that really add up to meaningful noticeable changes later on have helped things. And we're like extremely friendly with the guys over at Jump and the work that they're doing. Yeah, we needed to slow down a little bit to kind of help that car catch up, but also I think it's extremely useful to have a team from the outside sort of analyzing the architecture, analyzing the client, and forcing us to kind of relitigate some of our priors. You kind of build up some of this conventional wisdom that's hard to challenge from the inside. Maybe even new people come in and with fresh eyes kind of look at something, but it's no, we can't change this. It's too taboo. But when you have these people that are building a new client, it really forces you to revisit those things. And I feel like you end up separating what is just myth it's like, hey, this doesn't really apply anymore, from actually earned conventional wisdom that still holds. And so it's really healthy. I think the relationship is friendly. It's still competitive. We each want to build like a client that rocks and is awesome and that people want to use, but like that sort of friendly competition can kind of push us both to be a lot better.
Yeah, I think it's cool that I think Anza has come out of its shell in the last 12 months. That before, you had to be in the Solana Discord and see a lot of discussion there. And I mean, you guys have become, I think, much more visible in the role you play. I think there's definitely some friendly banter from Alessandro and Trent on kind of how Anza and Fire Dancer have definitely some friendly competition there, and exciting to play out. I mean, from the Anza seat, what do you think is the optimal composition of client diversity once Firedancer is sufficiently reliable to be on mainnet.
Yeah, I would love some future where we have 4 evenly staked clients and any given client could hit some catastrophic failure and the network just keeps humming along and no user has to notice. So that would be phenomenal. We're obviously not there yet, and so I think some people go, "Hey, this is all pointless," and we only yield the benefit when we're in that future state that I described. I actually don't think that's exactly true. I do look forward to a day where Frankendancer, has more runtime, more trust, and eventually Firedancer, and we have like a fairly even stake split on mainnet. And I think it's still de-risking, still just having a second client implementation. We still run these things a lot on testnet. Some of that variation and mix can uncover issues that are hard to discover with like one homogeneous client. And you also get diversity in terms of different releases. Like in a way, if you've got version N of Agave and version N+1, that's kind of like two very slightly different clients that are behaving there, and the same thing with kind of a Firedancer update. And so you still kind of have more than just a couple variations, and you throw the Jito Solana validator in there. It's like, okay, we've got enough diversity now that you're kind of blending all these things together and finding bugs early, and one kind of subtle issue with one client isn't necessarily taking everything offline. And it's really cool the types of things that enables when you kind of have some trust that one small mistake isn't necessarily taking the whole showdown. You can take some bigger swings, some bigger risks, refactor larger areas of the code, and just have more confidence that you can do things correctly, while still kind of maintaining consensus with the other clients.
Yeah. I mean, I think, Lucas, how do you think that Jito's validator client fits into the future where there's 2 clients on Solana mainnet with varying market shares?
Yeah. I would say that at least I don't have any strong feelings on being in the client game for a while. And yeah, it's like managing a client's a lot of work. Anza has a huge team. Firedancer does too. I think the client in my mind is like a means to the end of trying to build more efficient blocks. And I would much rather us take some of the resources that were focused on Jito Solana, and if some features of those gets merged into upstream, or whatever that looks like, we can take those resources, compound it back into trying to make the network more efficient, contributing to Firedancer and Anza, and just making the network much faster across multiple clients versus like the overhead of managing the Jito Solana client.
Yeah, there's some fragmentation there that may not be necessary.
Yeah.
And I mean, Tolly is fond of kind of arguing that 2 clients enable Solana to actually move faster because there is redundancy in the event of failure. How realistic would you say is that kind of idea that you can actually kind of be a little more nimble when there are alternative clients on the network?
Yeah, I mean, I think that you can bucket like catastrophic failures into 2 unique buckets. Like one is more of the safety security bucket, and the other one is the liveness bucket. And so I think it's a little harder sell on the liveness issue because if you truly have just 2 clients running even stake split and one of them has an issue, then you can't confirm blocks. And so I think there is nuance there, which is the piece that I just covered about like different versions are kind of like many different clients. And so there's the possibility that you can improve some of the liveness stuff as well. But I think the much easier argument, where I definitely agree with Tolly, is on the security side. If I'm a big operation and I'm dealing with off ramping or on ramping large sums of money, I'm just going to be running both of these clients. And now the odds that they have the same sort of bug where I have some invalid state change and I mess up the accounting, the odds of having the exact same bug in both clients becomes a lot less likely than just a single bug in a client. And so there's a lot more security over there. And so I definitely buy that piece of his argument. The other piece, little bit harder sell. I think we're kind of living that experiment right now as Frankendancer ramps up in terms of stake on mainnet, and so far so good. I think we've had success kind of testing some of these things out on testnet and seeing some issues and seeing things kind of limp along and looking at what incident response looks like and all those things. So I'm going to stay bullish and optimistic for now. But yeah, we'll certainly have growing pains.
Yeah, but it's been good so far. And I mean, I think we're about to get into kind of all the roadmap that you guys have for what's going to be changing for 2025. But I think it's helpful to look back a little at there's like a few eras of different bottlenecks in the Solana network, I think, from my perspective. And I don't know if like Brennan, you want to start with kind of like recapping what you see as, in prior generations, specific bottlenecks and kind of where we are today with what bottlenecks exist.
Yeah, that sounds great. So, kind of a trip down memory lane on some of the major issues that we've had to go through. I think in the 2021, 2022 timeframe, we essentially just had I'll call it a good problem of lots of volume. Um, you could call it a DOS. Maybe that's a little too generous because I think it was like a lot of real demand for popular NFT drops and coin launches and things like that, and essentially just validators getting overwhelmed. We didn't have proper back pressure handling. Queues would kind of grow to the point where we were dealing with them inefficiently. All sorts of issues like that. Gossip, Turbine networks getting overwhelmed. A lot of this would culminate in validators running out of memory and eventually the process dying. And so we had some liveness issues related to that. So obviously not a great spot to be. This took a lot of different things to make better. We had to optimize Gossip and Turbine, add in some load shedding, kind of the escape hatch if you're really kind of running into problems or suffering like a real DOS attack. Priority fees came in 2022. We added Quick for transaction ingestion. We increased hardware requirements. So it took a lot of different kind of things to get this situation under control so that at least under immense volume, we weren't seeing validators crash. We could at least continue surviving, making blocks, voting on blocks, confirming things, and keep the network moving along. So that was really important, and that helped get things to at least liveness was pretty good. But I don't think the user experience was necessarily great during those times, during those popular launches. And so that kind of brings us forward to more of the like late 23, kind of early 24 maybe timeframe, where we had a problem with the scheduler in Agave. And so, we referred to this particular scheduler as the thread local multi-iterator, which is a mouthful. But I mentioned that because, it's gone through multiple iterations here. It continues to be like a big, awesome innovation surface and really important for like adding value to the network. It has such like, it's probably the most important area when we think about like user experience and also validator economics and all sorts of important things. And so, the thread local multi-iterator, this version that we had a couple of years ago, had two main problems. And it stems from the fact that we just kind of like indiscriminately would fan out transactions to the execution threads. And so none of them had a global view of account locks or priority fees. And so you're making these local kind of suboptimal decisions, which means you're kind of wasting time on execution. And then there's also a little bit of unpredictability on priority fees. Like, I think that users can handle, like, if you can't necessarily meet all of the demand with block space supply, like we would like to, but if that's not happening, but at least it's predictable. Like if I'm willing to pay a priority fee, I can get inclusion. That's an okay user experience. And that wasn't the case. There was a little bit more of like luck of the draw. And if I ended up on this thread over here that had a bunch of high paying users, maybe I got dropped even though I was willing to pay a decent priority fee. So that was not a great place to be. And that's what led us to the central scheduler, which gave us that global view into account locks, global view into priority fees, and we could sort things by priority fee per CU, and then build out this big priority graph. And so it was just a much more fair way of getting transactions to the execution threads, and really kind of improved some of that user experience. So that was great. That was a big leap forward. But the last thing that I'll kind of mention that really kind of helped things was, even though with that central scheduler, we got to a place where, like, the way I view it is, whoever was in the auction house, like, we were accepting the highest bid for whoever was in there. We had a problem with getting all the right people into the auction house. And so sometimes, like, the highest bidder was like, I can't get into the auction house to go cast my bid, which again, like, not a great user experience. And so that the solution that we applied to that was this stake weighted quality of service, or SWQOS, you'll see. And the idea there was, the number of people that you get into the auction house is correlated with the amount of stake that you have. And so this is not like a perfect solution, because I don't necessarily think that high stake means quality transaction flow. But there are a few things that I really liked about this solution. And so one is, it gives even more utility to Sol, the token, which is great. Like, you have this, it gives you like ingress bandwidth to the leaders, which is really cool. It also incentivizes clients to prioritize their higher quality bids. So it disincentivizes like bad behaviors like spamming. And then also, just kind of more of a design decision related to this, we kept like 20% of the bandwidth available for unstaked connections, which I think is really important, because you have some of these more creative but maybe like less capitalized projects, think like research students and things like that, and giving them an opportunity to still like transact and actually be able to land transactions on the network is also super important. So yeah, I think those are like the three major things I would say, like better back pressure handling, better scheduling, stake weighted QoS, that kind of brings us to where we are today.
Yeah. And I think, like, zooming out, it's important to understand the ripple effect of how some of these inefficiencies actually compound themselves, right? And so, like, the jitter in scheduling, the jitter in transactions actually being received by the validator to get scheduled, resulted in levels of randomness where if you wanted the transaction to land, you don't just pay more and you have it land. You end up having people, use bots that end up sending 100 transactions a second, because it's at very, very cheap fees. And like, that's actually the more profitable strategy. But then you have everyone sending 100x what they actually want to do. And, it creates like the ingress challenges, and it's even harder to schedule, and it's even harder to, deal with kind of who should the validator be listening to. And so it's, I think there's a lot of benefit of how efficiency actually results in much, much less traffic, because it's more targeted and actually deterministic. But I mean, stake weighted QoS, I think, has been a controversial topic since it was introduced last April. I don't know, Lucas, like, how do you think that system may evolve from kind of the V1 that was implemented as like an emergency bug patch into what is like a more sustainable mechanism?
Yeah. I go back and think of Trent or Anza. I don't know. Trent says it a lot. I'm sure Anza says it internally, where it's all the bad decisions were the right decisions. So I think at that time it made sense, and that's just nature of working in fast-moving organizations, where you have to. There's a fire, and maybe you have some idea of what the right solution is at the time, but you need to fix it ASAP because people are counting on you, and there's people complaining, and the user experience is bad or whatever it is. So I think that stake-weighted QoS is fine, but to a point Brennan made earlier, the cool part about stake-weighted QoS is it provides some value to Sol token, but I think Temporal has been working on this, and there's been discussion about doing something like a fee-based quality of service, or some type of reputation system, to where it will keep a connect. If you're sending more high value transactions to the leader, it will want to keep the connection open to you. So if you're sending good flow, where good flow is defined as things that pass signature verification, not a lot of duplicates, things that pay high fees, transactions that land that aren't like already processed or have missing fee payers or whatever it is, then that means that you are going to make more money. Your hourly rate essentially goes up. So how much money you're making per hour or per compute, like per clock cycle or per memory usage or whatever, goes up if you're getting a high quality stream. So I think that that's probably a direction that I see things going in. Of course, there might be second order consequences of this that need to be examined more, but I think that something that prioritizes based on sending me the highest value, most efficient transactions that I can do the least amount of work on to make sure that they're valid is probably a direction that the networking stack goes in and on a longer time horizon. But yeah, I think that there's also some discussion on, I think it's probably pretty heavily contested inside Anza and other protocol teams on quick, and it's quick overkill. I know that people at FireDancer had a lot of fun re-implementing quick from C in Scratch. So yeah, there's certainly discussion of other protocols that might be simpler that you can offload to hardware that whether it's like 00 or FPGAs or something that that could kind of change the way the networking stack works. But yeah, I think from our standpoint, both as we operate validators at Jito Labs just so that we know, like, if you're going to be shipping a validator client, you need to know how it works and how to run it and what people want. The networking or just the entire client in general has gotten so much better over the past few years. I think back to, Lane, like a year ago, or maybe it was less. It's like, oh, my validator's been running for like a year straight. And that was a huge accomplishment without any downtime. And thinking back to like early to mid 2022, where things would just kind of randomly restart, or there would be some panic or something, or out of memory. It's just really cool to see how fast they've been moving, but also focusing on the fundamentals and like making the software super reliable. We've seen it in the network, and I think users have noticed too.
Yeah, something I've been thinking about, like the Solana Discord used to be so busy because validators would just crash all the time and like figuring out, there was all sorts of issues. And now like you see very little of that for experienced operators because the reliability has come up so much. And so we've kind of moved on to new pastimes about debating SIMDs and other things. But it's definitely like refreshing how much it's improved before, and like the level of chewing glass for validator operators has come down by a significant margin, at least in the technical sense. And I mean, I want to get into the other network changes, but I do think it's like an interesting case study, right? Whatever happened with Segwit and QoS, it was like a very serious network problem because back in April, like you could not really land transactions reliably. It was challenging. And like maybe Brennan, you can just like very quickly walk us through what the process actually is at Anza. So like you guys have a ton of monitoring on the network. Like how do you like kind of spot new emergent problems and then diagnose them, test, roll out, right? I mean, I think people probably don't comprehend the level of work that goes on behind the scenes and just the timelines to reliably roll out fixes to these types of things.
Yeah, I'm happy to walk through kind of what that incident response looks like, how we get observability, how do we actually, go cradle to grave on resolving some of these important issues that come in. And so, it starts with some of that monitoring and observability. Of course, we have, watchtower things for big macro metrics and big things going wrong. Things like slot times, transactions advancing, latencies, dropped requests, all of that. And it's challenging sometimes to get observability because this is a decentralized network, and so we don't control all the boxes. But we do have a good amount of validators that opt into reporting metrics, and so you can kind of get a partial view of how the cluster at large is behaving and make some good assumptions based on that. And so oftentimes for things like this, we can look at ping clients and things like that for reliably landing. It's kind of a controlled environment where we know what's being submitted, what's the priority fee, all of those types of things. And it's a really good proxy for the end user experience. Like at the end of the day, if you can apply, reasonable median priority fees and get your transaction to land in a useful amount of time, that's really what people care about. And there can be a lot going wrong kind of under the water that you can, you have the luxury of time to fix as long as that kind of stuff is working. In this case, it was very obvious that things were not going well because even those kind of simple ping commands were not reliably landing. And so it was, very much in our face that we had some issues here. And you could kind of see it coming in waves along with, increased ingress into a lot of these validators. And so then you can kind of go one layer deeper to understand what's going on. And we have a lot of dashboards and things that we'll monitor to try and understand the health of the network. In this case, you start seeing things like ingress spikes, how many transactions are actually coming in. We can see how wild the deduper is going because kind of to your point, before some of these solutions, you're incentivizing really bad behaviors that just compound the bad things that are going on. Like it's not about priority fees, maybe it's more about spamming. And we can observe that spamming happening by watching certain things get deduped, or maybe there's small amounts of entropy and things go through, but they kind of get filtered out in some later stages of sanitization. And so we were very clearly seeing all this work that validators were doing to ultimately not be able to land transactions because there was just a lot of spamming types of behavior that were going on. And so, in this case, a lot of our existing monitoring and things made it pretty clear what the problems were and kind of what was being incentivized. I also kind of go, hey, it's cool that we were having enough success that people wanted to spam the network and like the economic interest and things were there. So these are the type of problems that you want to have as an engineer, like you're solving important stuff. So at that point, it was solution space, and I agree with everything Lucas was saying earlier on stake weighted QoS having its problems and like it's really just kind of a proxy for good flow, or at least we believed it to be, and there are like a bunch of other things that we could do. And so, we're huddling, we're like aggressively attacking this problem with a lot of the big brains, thinking through all of these solutions and people kind of putting those forward and figuring out, okay, like what does like a mini roadmap of this thing look like? Because we don't have the luxury of waiting, 6 months to roll something out. Like we need to do something now. And that's where stake weighted QoS kind of emerged as the consensus pick, as something that's very quick and, pardon the pun, but, easy to roll out. But it requires more buy-in. We talked about some of the friction in the process. When you have more people kind of in the mix coming online, you need more buy-in of people kind of implementing the solution. Like it can't just be a PR coming from Trent to make this change on the network. And so you have to get buy-in from some of those stakeholders. Again, I think because of the degraded state of the network, it was easy for people to rally around something that was kind of easier, lower risk, and that we were convinced would solve the problem. Thank God we had invested in Quick kind of a couple years earlier, because it allows some of the kind of primitives in that protocol to be able to constrain like the amount of transactions you can send per stream and all those kind of good things. So it was a nice foothold to be able to attach some of these things. But getting to your question on the tactics of what does it actually look like to fix this, we had to make some changes, test it in controlled environments. We have canaries that we run on some of these networks, and so we can kind of run individual isolated changes without upgrading the whole fleet, make sure it's actually behaving like we expect. We are actually clamping down, on spammers and that sort of a thing. And then, kind of quickly get some stuff rolled out on testnet, test out some changes, and then make a patch release on the main version. Something like this is usually bigger than what we would recommend for like a backport. We usually want to soak things for as long as possible on testnet and really have high confidence in it. But again, this comes down to risk appetite. And in this case, the risk of more aggressively backporting something like this and getting it rolled out to the network can outweigh the risk of not doing anything, having a super degraded user experience, having people leave because the experience is bad enough. And then going slow is risk.
Yeah, no, I think it's a big accomplishment to be able to solve that in such a short period of time. So I don't know, Lucas, were you going to say something?
Yeah, I think these are all, while extremely painful for Anza and Jito and all the other teams that were dealing with this, I think it's incredibly useful that this activity was happening, whether it's meme coins or NFTs or other things. I think like extremely painful, but it was, I think other networks should want, obviously you want this activity to take place because it means that you're building something people want, but it's also extremely extremely useful to have this type of demand because you just find the most critical things and most critical performance bottlenecks that you need to scale. So yeah, I think like the meme coins were super valuable from that standpoint because like who knows what Anza or the ecosystem would have been working on if there wasn't any of this activity taking place. Like I don't even know what was dropped. Maybe you can shed more insight into that on like what was dropped to scale and handle this to get all the engineers hands on deck, because like this was in my mind extremely critical for like comparing 2023 to now.
Yeah, I don't even remember all the various things that we had going on at that time, but for better or worse, priority by fire is extremely efficient. Like it's so easy to rally everyone around a giant blazing fire like that and be, you know, crystal focused. And so like when you don't have something like that, sometimes you need to rely on a little bit of mission statement sloganeering, something like IBRL, which has, you know, power in itself. It's easy to rally behind. It's a simple thesis. In this case, it was a pretty simple thesis, like make, you know, disincentivize spamming, make people that are willing to pay, you know, medium priority fees be able to land in blocks. And so we had, you know, some other, you know, work going on in the runtime and you know, some scheduler work, some performance work, some block store work, like all sorts of various domains. But yeah, at that time it was like all hands on deck, all the systems generalists, anyone that can add value here. You know, this is the place to be. We'll swarm it.
Yeah, and I mean the network is in great shape now. So you know, we're getting into like what's next, but I think people like kind of not in the weeds probably haven't realized like the difference in skip rates and epoch time that has happened recently. And so I don't know, Brennan, like if you just want to walk through kind of what that means from a very high level and like why as you know a user that is you know aping meme coins on pump.fund, like why that impacts them and why they should be celebrating the changes that we've seen from Anza.
Yeah, the V2.1 Agave rollout on mainnet has been super exciting because a lot of those important macro metrics have improved in meaningful ways, and people are like truly noticing and appreciating all of that hard work that went into that. And so some of those important metrics are like the slot and epic times, like you mentioned. And so, you know, most people know that Solana targets a 400 millisecond slot or block time, but they may not know that it doesn't always mean that it actually achieves that 400 millisecond slot time. Like the real world can get in the way of that. So things like network latencies or like long execution times or very untimely pipeline stalls, all that kind of stuff can lead to, you know, actually slightly elongated slot times. And so the actual slot time is really like an indicator of how smoothly our transactions getting into the system, packed into blocks, those blocks getting sent out to all the validators, getting executed, updating the state, all that kind of stuff. And so, yeah, that's all those metrics improved. And you know what it like really means for the meme coin aper on pump fund and that kind of a thing is, you know, shorter slot times mean lower latencies, and so it's everything feels a little snappier in terms of when things actually get confirmed and when transactions land. Um, you know, milliseconds kind of matter for that sort of a thing. It also can mean tighter spreads on things. You know, the shorter latencies are kind of, it reduces some of the information asymmetry, and so you know I think a lot of people don't appreciate that sort of a thing. It also helps with like better validator economics. You know, the more transactions we're pumping through, economics kind of get better there. Oftentimes those kind of cost savings can get passed on because you know it amortizes a lot of those operational expenses. And so it helps, you know, a little bit in a lot of ways that might be slightly non-intuitive. So that's like the slot and epic times picture. Um, you also mentioned skip rate, and that's like one that has just come down to the floor. Like we've had major issues with this in the past. If you look historically, like it's been like 10%. significantly higher than that if you go far enough back in history, which is kind of insane to think about now. Now it's more like 0.5% on a bad day, oftentimes lower than that, which is fantastic. And for those that aren't familiar, skip rate is basically a function of like how many blocks actually got built on the canonical chain versus how many chances did we have to build a block, or like how many slots did we have. And so you might have a chance to build a block but not actually build it because of things like the leader may have been delinquent or offline when it was its turn. It may have been slow during that time, so kind of some of this like unpredictability in performance oftentimes came up at the worst possible time, and they were slow and they just kind of missed their window to build a block. So we see things like that. Or it could be like a network partitioning or forking scenario, or maybe they built a block but it was on a fork that ended up not getting confirmed. My analogy that I think works well for this case is I sort of think of it as like factory yield loss. Like if you're kind of making some physical product in a factory, there's always some percentage of yield loss. And it's really just like economic loss or economic leakage that ends up costing everyone. So it's like a tax on validators, it's a tax on users, because it's just overall fewer kind of transactions that come in there. It also of course impacts latency and things like that, and just overall user experience. But yeah, it's really cool. I'm really like pumped up over this one because it was so much work that went in over the last 6 months to make just minor improvements here and there, and then boom, in v2.1 it's like everything got better, all those macro indicators that the nerds care about.
Yeah, I mean, I think we've all been there back in the day when you click Phantom and it just spins for like 60 seconds, and then transaction expires, then you re-click again, or you just like click like incessantly and like land like 5 of the transactions you wanted instead of none of them. And I mean, I personally haven't had that in a long time, and so it's definitely like the UX is just tangibly so much better than it used to be, and it's like really really awesome to see. But job's never finished, and so like, what do you guys have in mind for 2025? You put out a blog post on the Anza blog that we can put in the show notes that kind of talks more tangibly about a lot of steps. I mean, what are the major things that you think will impact the network, and like how does that translate again to the user experience being even better than it is today?
Yeah, so some of the main focus points for Anza in 2025, I mean, really it just comes down to one thing. We want to go increase block space. So it's the IBRL tagline that we love to meme so often on X. But it really is an awesome rallying force for the entire team, and there's tons of projects that can kind of go roll up under that one unified vision. And so when I talk about increasing block space, it's really like pumping up CUs or pumping up kind of the total transactions that we can pack into a block. And so why does that matter? Well, the more kind of throughput that you have, the lower median fees will be, the easier it is to land all the time, but especially during these peak demand and times of congestion, there's just more space for all those transactions to go get included. So that's really the big rallying call. And I feel like so many of these audacious announcements that I see, like they end up getting so watered down or so caveated that by the time they hit like the user experience, it's like, okay, cool, this is like, it's not turning the needle that much. And I want to be really clear that like that is not this. Like we're not improving some BS synthetic workload metrics or anything like that. Like we're doubling real throughput for things that people actually care about, like swaps and like meaningful complex transactions. And so this will be noticeable, especially during those times of congestion where we're like meaningfully marching performance forward. And so there's just like too many things to even go through in terms of how we're actually improving performance, and so many different people that are like making awesome contributions here. But I will call out like kind of a few important things. So one is just aggressively attacking all memory allocations. So I think that like, maybe the intuitive thing that people think about is like the changing algorithms and like optimizing for compute and stuff like that, or maybe like the leak code generation thinks that that's important. Like it's not actually what matters for the validator. Moving data around is the really expensive part. And I know like Kevin Bowers is always beating the drum on this, that like there's too much magical thinking about how computers work, but moving data is really important. So any sort of extraneous allocations and movements and things like that, and avoiding these M advice storms and all of the like nerdy things that I could talk about for hours. Like that's what's really important. We did a bunch of that over the last 6 months, and that's a huge part of why V2.1 was really great. But yeah, job's not done. So we're continuing to kind of aggressively prune those out, prune out the allocations, prune out any unnecessary system calls. So that's one thing. The second thing I'll call out is improvements to Turbine. So when I look at what is kind of preventing us from just like doubling throughput and doubling block capacity today, it's really getting all of that block data out to the rest of the network. It's Turbine is the protocol that we use to actually go do that. And so without going too far into the weeds, it's not even so much like a NIC bandwidth problem as it is more of an IOPS problem with the way that Agave has implemented this. The turbine is like a big tree, and you've got nodes at the top that need to fan out that block data to their children, that then fan it out to the next layer, and so on. So there's a lot of egress pressure at the top of that network, and just a lot of IOPS to handle, and send message syscalls to go send out all of that block data. And so we've been aggressively attacking that. I think a lot of people are fond of following Alessandro's work and some of his spicy tweets, and so he's like been going like full nerd on this problem, and skipping, kind of bypassing the kernel for making this more efficient, and using AFXDP to expose this to user space, which is just a much more efficient way of not having to do some of these intermediate copies of data and just getting that block data out a lot faster. So that's a really meaningful thing that we think really paves the way to doubling block space this year. And then the last thing that I'll mention is just there's this big bucket of like not doing dumb stuff in the validator. Like, yeah, Trent's got the famous quote that all the bad decisions were the right decisions, and like that's probably true. It's cool that we built something that's now useful enough that we need to go like crank it and squeeze blood from it to go extract maximal value out of the validator and get max performance. But there were a lot of just dumb quick things that we did along the way, and so like too heavy of hash functions, serializing and deserializing the same structures over and over again. These are like things that we're doing multiple times per transaction in the hot path or per shred in the hot path, and like they add up. So just getting slightly more efficient on little things like that all the time can really turn the needle when you do that times 1,000 through all these different paths. So yeah, TLDR, we're going to double block space this year. It's going to be great.
Yeah. Anything, Lucas, on the roadmap that like stands out to you that you think is especially meaningful or overdue?
I think we're pretty in the weeds here, and that's the area I love to be as an engineer. But I think ultimately it's all about the users and the user experience. So making people's transactions land faster, adding more block space will hopefully, maybe at some point we can bring down the transaction fees and make it cheaper, and that will cause more people to trade on chain and more liquidity and all that. So yeah, I think it's all about the users and the user experience, and these are just like really cool and some not so obvious and some obvious changes that will result in better user experience for everyone on Solana.
Yeah, for sure. And I mean, from a non-engineering perspective, I think there's like, Solana loves big boxes, and it's like, yeah, memory allocation and IO is cool, but like, let's just get bigger box and a better internet connection and like solve it that way instead of grinding through all of these software optimizations. Like, to what extent is hardware the bottleneck today, versus the software stuff that you guys are, talking about so far?
Yeah, I mean, a bigger box always helps as long as you're, vertically scaling it in the areas that matter. If you're not doing that, like Amdahl will teach you pretty quickly that, speeding up the part of the assembly line that's not the bottleneck is not really going to help things. Oftentimes it can make things worse by just piling up even more work at the feet of the true constraint. And so, it can help. It never hurts to have really, really solid, high-powered hardware, especially when it's applied to the right bottleneck. But yeah, it certainly doesn't solve everything. And there are problems like when we look at this memory allocation, like, cool, maybe it gives me, a larger pool of memory to churn through. But at some point I've got to pay that cost and like return that fragmented memory back to the kernel, and I'm going to pay the page fault penalty. And so yeah, there is no real free lunch here. Also throwing, bigger hardware at it is like a very expensive way of solving this problem. And so, I can tell you about the mindset at Anza. Like when we look at these performance improvements, like some people try and throw it in some special category of like feature work or its own sort of vertical in terms of engineering work. We like think of these as bugs. Like every performance bottleneck that's like some part of the system not just running at line rate is essentially a bug that needs to be squashed at some point. And so that's a much more effective, like cost effective way, but also faster way of increasing the performance of the network. And also, I mean, it's important that like we can't just have one validator run some better hardware and everything magically gets better. It's really we need to raise the entire minimum hardware specs to truly be able to reparameterize the cluster around those hardware specs and build in this expectation of higher block capacity. So it's really like, I think Moore's law will do its thing and hardware is going to get better over time, and we expect to kind of ride that wave. But in terms of like aggressively climbing the hardware pipeline to like, as a means of improving performance, like we just need to fix the software bugs. It's such an easier way of getting there and more impactful today.
Like, how do you guys think about, right? I mean, all the wrong decisions were right at the time, and like a lot of this stuff was known and like somewhat obvious, but like, what's the level of kind of changes to Solana core, which is an ambiguous concept, but like, versus the amount of changes that you guys are doing that are simply like optimizations, fixing tech debt, all of that, right? I guess like maybe IBC is kind of like a new innovation that is actually fundamentally better. But how do you think about that trade-off? And are there other changes that are kind of behind the scenes on how Solana was designed initially versus how it's implemented today that you guys have done?
Yeah. So we have a lot of internal discussions about finding that right balance between shoveling tech debt versus like advancing the protocol forward or our client implementation of the protocol. And there's certainly like healthy disagreement and technical tension on the right direction. But I can tell you my opinion. I'm definitely far on one side of the spectrum here. I think that it's all about protocol improvements. Fixing tech debt is really a means to an end, in my opinion. And the idea is that by shoveling some of that tech debt, it ultimately just helps you ship protocol improvements faster. So that's the end goal. And having tech debt, again, means like you've probably done enough things right that the project still matters, that people want you to iterate on it and go make it better. So that's not necessarily the worst problem to have. It means you've built something that people want to use. But I want to be clear, like this doesn't mean that we can just ship unreliable junk. It doesn't mean that at all. Like things have to work. They have to be resilient. But I'm definitely in the camp of like we cannot let the optimal solution severely delay the incremental improvement to the network. And I think that something like stake weighted QoS is a good like concrete example of that. We could have done, waited for the optimal solution. I really like a lot of the things that Lucas said on this topic earlier. But it would have delayed, a very important incremental improvement. And so I think that's kind of the right spot to be. That said, we have a lot of really smart engineers, smart people working on hard problems and can see kind of where we want to evolve the protocol. And so if you look kind of back at the Solana Labs client and where we are today, we have, been able to shovel quite a bit of that technical debt, reducing a lot of these extraneous memory allocations, being a little more intelligent on shrink wrapping the client around, the actual use cases of the network today. And we're in a much better spot to go, expand the protocol, go aggressively attack, some of the problems of tomorrow or 1 month out or 1 year out. So yeah.
Yeah, and I mean, I think there's interesting kind of less technical, I'm still technical, but like not in the weeds on the code efforts that Anza has kicked off, right? And so it has some researchers that have kind of wrote up a core spec. You have Mac Resnick as chief economist at Anza now. How has that changed you guys' process on like zooming out on some of like the fundamental principles of like how Solana should work, and if they were, the correct decisions at the time, or like in hindsight, we have these type of changes to make?
Yeah, I think it's been a really worthwhile experiment bringing in a lot of this thought diversity. And so like the researchers that come more from that academic background and, Max bringing him over from the Ethereum ecosystem, right? There's a big diversity of thought. And I think it's, a great part of the Solana culture that we sort of embrace that disagreement. We'll kind of fight with each other about what the optimal solution is, and there's a lot of passion about what the right thing to do is there. But then at the end of the day, everyone can kind of stay data driven and look at things and come to some consensus on, okay, what path do we take forward. Like the worst thing that we could do is get into some sort of groupthink model and super tops down decision making. I think it's awesome to bring in a different mix of minds and backgrounds to kind of relitigate and rehash some of these problems that come up. And so that's been really cool. An important part of making it successful, though, is that kind of base culture and making sure that we don't lose that sense of it. We don't want to lose some of that identity of, hey, we want to aggressively ship, incrementally improve, kind of get something out that works, iterate on it, learn, kind of reevaluate things and stay low ego. And so, we've had to kind of mesh all these different personality types and teams internally to kind of go make this thing work. And there's growing pains that come with that. But I think you're starting to see, some cool things come out, and Max being very vocal about like some economics changes we should make, and the research team kind of rethinking, some of the consensus decisions, and some really cool ideas, and kind of showing some of the future possibilities of things that we can go after.
Yeah, I mean, some of the stuff that has been found in a very short period of time from the research team you guys brought on is super impressive. And so it's really exciting as we get more eyeballs in those domains. I think it kind of ties in, right? I mean, the process and how people think about it is decentralizing. And I think from a technical level, there's somewhat of a movement to decentralize or like modularize certain elements of the validator stack. And I don't know if like Lucas, you want to kind of like give a little more detail on like what that means. It would be interesting from you guys to like hear how you like what level of modularity makes sense and why it might be good for the network.
Yeah. I think there's certainly pieces of the stack that have been modularized and are starting to modularize. So the Jito relayer was kind of one instance of this, trying to modularize ingress and deduplicate and signature verify traffic, and double zeros, another step in this direction, kind of on steroids. So using FPGAs and very dedicated hardware to not only do TPU in like transaction traffic, but even at a more fundamental level, the modularize the fiber that the data packets use to communicate with the rest of the cluster to get very low latency, low jitter information propagation across the cluster. And then there's also a little bit of modularity at the scheduler level, not necessarily baked into the client today, but kind of you have multiple schedulers running, whether it's the priority graph scheduler that Brennan touched on later, or the more recent greedy scheduler, and then Jito is kind of a simple scheduler for bundles. So I think it's kind of, in my mind, the L1 can do a lot to do this, but there's also some opportunity for modularization at specific parts of the stack, whether it's the fiber or the ingress or the scheduling. And that will kind of take place at where there's tweaks in these systems can create large economic outcomes for validators and stakers. And so I think we'll continue to see this happen, and it will likely continue to follow the IBRL path that Solana set on.
Yeah, I completely agree with everything that Lucas said. And I think the modular Solana architecture makes a lot of sense. I want to hijack this a little bit to stand on my soapbox, because there's like this lazy argument that I see thrown around all the time on X, that like, the Solana thesis will never work, or the architecture is broken because the whole world can't run on one computer. And I'm like, well, yeah, I mean, that makes sense, but it already isn't. Like Lucas said, you've got the Jito relay or block engine. I mean, this is already multiple computers like powering this block building process. And I don't just mean, number of validators, right? It's like we already have some modular servicing and all this. And so like there's a big difference between sharding the state and a microservice oriented architecture. Like I think we've kind of drawn a line in the sand with Solana and that, hey, sharding state sucks. But sharding compute makes a lot of sense and having separation of concerns. And I think it's challenging. It's harder to reason about oftentimes when you have different boxes doing these different things and you need kind of more strict communication protocols between them and all this good stuff. But that's kind of like the chewing glass aspect of being a dev on Solana that makes it worth it. You know, if we can go deliver a superior user experience by moving to more of this modular kind of microservice-y type architecture, you know, it seems totally worth it to me.
Yeah, I agree completely. I think certainly makes Anza's job of monitoring the network harder in some respects because there's a lot more variability in individual validator performance and what's happening there. But obviously, more experimentation by validators and optimizing specific pieces is only a positive for the network. And they should have an entrepreneurial job of trying out these things. So I think my last question is just kind of on MEV. Obviously, Jito is very involved in that space. It's created a lot of problems for Solana and Anza, I'm sure. But like, how does Anza think about MEV and how that should dictate some of the roadmap and decisions of the core protocol?
Yeah, I mean, I think the most straightforward way for the L1 to address MEV is like by reducing latency and shrinking spreads and IBRL and kind of the same sort of mission statement that I've been trotting out here for a lot of these things. It really does just help mitigate so many problems. And so I think that's kind of the most obvious thing where we can put the blinders on a little bit and just make this thing fast. You know, it shrinks some of the information asymmetry, tightens spreads, you know, some good things there in addition to all the other benefits that we've already gone over. But we're also thinking about some simple primitives in the validator protocol that can be exposed to kind of help the upper layers restrict some of the bad mev that can happen. And so, you know, I think we're still noodling on a lot of these, but like one of the single largest architectural changes in the works is, you know, that we believe will reduce some of this bad mev is having multiple concurrent leaders. And so there's, you know, kind of a long dependency of things that need to go be delivered to kind of go realize this vision. But you know, I think like one of the major problems or most significant problems that we have today is that each leader, when its turn comes around, because of it gets 4 slots at a time, it basically has a 1.6 second monopoly on all block space when it gets its turn. And you know, everyone kind of knows intuitively monopolies are bad for customers. Competition is good for customers when it comes to this kind of a thing. And so having, you know, multiple block build, multiple leaders at a time that can kind of compete for transactions or you know, compete for blocks is going to, you know, shrink margins and reduce some of that you know, kind of bad mev that we see. And so, you know, all that said, I don't think it's necessarily the job of the L1 to like introspect transactions or really put a finger on the scale to decide what's fair or, you know, which transactions are more meaningful than others. I think that's a really bad spot to be, but there certainly is a responsibility to expose like the tools for the upper layers to deliver, you know, the best customer experience, user experience possible.
Yeah. I mean, anything you wish you could see differently, Lucas, on the MEV side? Obviously, kind of introduce some changes there and very involved in that flow.
Yeah. I would say more transparency, like internally, like something we're pushing a lot towards in 2025 is more transparency. So how does our system work? What is it doing? What code is it running? What are the transactions going through it? What are the outcomes of that? And just more transparency in the validator set. I think the stuff that Ghost Logs is doing is super cool with their dashboards and showing a lot of the information propagation and what's happening in the blocks. So I think that's super interesting. And then I think trying to find ways, ultimately, we keep saying it over and over again, the increased bandwidth, reduced latency. I think that's like the number one thing to focus on for this. And I mean, when I started Jito, I didn't realize that the pressure would be so high and there would be this enormous economic incentive. But I guess that's just the outcome of working on a super successful network. So they're very painful. It can be very painful at times, and have to make we can be maybe a little more opinionated than Anza or core L1 engineers can be, but ultimately it's a sign of success. And I think it's a very interesting and challenging space to work in from a Mev infra provider. And I think a lot of the challenges I have in the Solana network in the past, the Mev game's certainly a lot different now, but a lot of it has come down to Mev or trading and some of the scheduler stuff that we were talking about earlier with the spam and people, spamming tens or hundreds or thousands of transactions at a time and having undeterministic ordering and things like that all come down to Mev. So yeah, I would say more transparency and more thoughtfulness from people in the ecosystem, whether it's the L1 core devs or the application devs or wallets with respect to things like Mev, will continue to give users the best outcome.
Yeah, definitely a lot more eyes on Solana Mev than 2 years ago when people didn't think Solana Mev existed. So it's been a fun ride.
Yeah.
I think we're up on time, but Brennan, anything you want to plug for Solana community members to kind of stay tuned on the ongoing updates that you guys are making?
Yeah, I mean, IBRL, that's the mission statement. Everything kind of falls under that umbrella. You can follow along. We're putting out more Anza blogs, trying to, to Lucas's point, sunlight's the best disinfectant, and, kind of give you an idea of where we're heading with things and shine some light on some of the cool projects that we're working on. But yeah, we're all pulling in the same direction. I think these are the problems that we were hoping for a few years ago. And so now here we are, and the job's not done. There's a lot of work to do, but it's, the work that we want to be doing. And so we're going to go make this thing fast. We're going to be able to, pack a bunch of transactions in those blocks. We're going to, go solve a lot of problems by doing that, keeping median fees low, keep those transactions landing during times of congestion, and, just stay like laser focused on that user experience. And so exciting things ahead. Yeah. Tune into the Anza blog to kind of stay up with what we're doing.
Yeah, love it. So thanks a lot for the time, Brennan and Lucas. And, maybe we'll have to circle back up sometime in 5 or 6 months and kind of see what's on the agenda for 2026. So appreciate it. And thanks everyone for tuning in.
Yeah, absolutely. Thanks for having me on, guys.